My name is Brad Ritchie. I work in QA Cafe's customer support team, and I want to welcome you to the webinar. Here we'll be explaining how to configure CDRouter for testing devices for IPv6 testing. This is going to cover the basics of getting your device set up with CDRouter to assign addresses to the device and allow CDRouter to create clients on both the LAN and WAN, or hosts on the LAN and WAN to communicate via IPv6 through your device. Right here I have a diagram showing a basic IPv4 network. You've got the WAN side on top with a public IP address and a LAN side on the bottom. This is probably what you're familiar with already with your testing. It uses the default addresses that CDRouter will assign if you don't change any of the configuration. Each of these test vars are settings within CDRouter's configuration file that you use to control the addresses and the other settings that CDRouter uses to initialize and establish your network test setup. So on the left side here we have the WAN settings, where by default CDRouter will start a DHCP server and expect the device under test to request an address. And on the left side, on the right hand side, we have the default LAN address that the device is expected to use for assigning addresses to CDRouter's LAN clients. So the same model is going to apply for your IPv6 testing. Here we have a similar diagram showing the WAN on top with an IPv6 prefix advertised by CDRouter. It's the 3001:/64 prefix is being advertised to the device, and the device will have its own prefix that it advertises on the LAN via both of these via IPv6 router advertisements. The default settings that CDRouter will use, unless changes are made, will be to support a DHCP server on the WAN, and the device will be expected to send CDRouter a DHCP solicit and request message to obtain its IPv6 address for the WAN side. And by default, we supply a 64-bit prefix to the device. On the LAN side, CDRouter will create IPv6 LAN clients that are configured to use Slack, stateless address auto configuration, using a random EUI64, modified EUI64 identifier. So CDRouter's LAN clients will receive a router advertisement from the device, and that contains a prefix, and it will take that prefix and apply its own interface identifier to create its own IPv6 address. This is the default mode that CDRouter's LAN clients will initialize in. This can be changed to DHCP-v6, as we will see in a minute. But these are the default settings. So if you create a new configuration file and not make any changes, this is what you will get. To begin configuring and enable IPv6 in your CDRouter config file, the first thing you need to do is enable it using the supports IPv6 test var. So this is found under the CDRouter IPv6 add-on section, and I'm going to jump over to a configuration file. So this is a sample configuration file that you will be familiar with. So when you create a new config, I'll just jump over to what this looks like. So this is a brand new config I'm starting to create. Doesn't have a name yet. And you can see in the bottom section, each of the configuration sections is broken out by the different add-ons that are supported by CDRouter. So in the base configuration is where all of the IPv4 settings go that you're probably already familiar with. You've got your WAN and your LAN section for your IPv4 settings. I'm going to close this up here and jump down to the IPv6 add-on section. And you can see within here, by default, IPv6 is disabled. So to enable IPv6, we're going to uncomment the supports IPv6 test var and change this to yes. And then you see that there's also a WAN and LAN section in here, subsection for configuring your IPv6 parameters. So we're going to go back and I'll cover the basics of setting up your WAN addresses first, and then we'll move on to the LAN settings. So when you expand the IPv6 WAN section, you'll see test vars that are similar to what you might see in IPv4, where you've got a WAN mode that determines how the device is expected to request its address from CDRouter. You've got address sections, and these are all highlighted in yellow. These are the main settings that you'll need to be concerned with for getting a basic test setup up and running. So the WAN mode is the first item that determines how the device gets its address, and then the actual addresses are set via the IPv6 WAN ISP IP address, the ISP assign IP, and the ISP prefix length. That determines what prefix CDRouter will advertise in its router advertisements and what addresses it will assign to both its own IP, its own WAN interface, and the address that it will assign to the device. So the ISP IP address is the address that CDRouter will use for itself, and the ISP assign IP is the one that will be assigned to the device via DHCP v6 in this case, or if you change how the address assignment happens, that's the address that the device will be expected to use. The prefix length, as I said, is the length of the prefix that's advertised in the router advertisement. And the other setting here, next IP, that's just an additional address that needs to be configured for purposes of renumbering. So if we're running DHCP v6 tests that attempt to change renumber the device's WAN address, that address will be used for assigning a new address to the device. So by default, we're using DHCP v6, but you can also configure CDRouter to allow the device to auto assign its own address, or you can assign a static address to the device. And in all of these cases, the device itself is what needs to be configured. You'll need to go onto your device and set up its WAN mode to either request address via DHCP v6 or via auto configuration, or configure a static address for that device. And then once you've made that setting, you'll need to go into CDRouter and set these test var settings appropriately to match your device configuration. Many devices support sort of a blended mode where they will attempt both DHCP v6 and auto configuration and use whatever works first. So in that case, even though your device may support multiple modes of operation, CDRouter will only support one mode at a time. So you're going to set up, if your device has a hybrid mode like that, you're going to need to choose which mode you want your device to operate in. And by that I mean CDRouter will operate either in DHCP v6 mode only, or in auto configuration slack mode only, or static only. So by changing the IPv6 WAN mode to one of those modes, the addresses are the same. It just in auto config mode or static mode, you'll need to match the ISP assign IP address to match what the device is going to use. You can also set up CDRouter to work over a PPPoE link. In this case, the WAN mode is set to PPPoE, and then there's an additional setting, the IPv6 PPPoE address mode, which has the same settings as the WAN mode. So this just allows you to use PPPoE encapsulation with an address assignment. PPPoE encapsulation for setting up the link, and then the IPv6 address assignment will occur over the normal mechanism based on the address mode setting. Okay, moving on. So many devices support and require a prefix for the LAN to be delegated from the ISP, from their upstream router or a DHCP server on the WAN. This is done through DHCP v6 Prefix Delegation. It's a special option within DHCP v6 that the device includes to request a prefix. It may do this along with its IPv6 address if it's using that for address assignment, or it may send DHCP v6 messages just for the prefix. By default, this is disabled in CDRouter, but it can be enabled underneath the IPv6 WAN section. There's a subsection called DHCP v6 Prefix Delegation. When you expand that, actually I'll jump over and just show you how to navigate to that. So here we have our WAN section. I'm going to expand that. And you can see the IPv6 address settings that we just talked about. And then when you scroll down, these subsections allow other services to be set up. And here we have prefix delegation. We'll expand that. And you can see by default, prefix delegation is disabled. So to enable it, at a minimum, you'll just need to uncomment the DHCP v6 WAN enable PD setting to yes. Uncomment it and set it to yes. And then these other settings control the prefix that CDRouter will assign and send to the device in its DHCP v6 IAPD option for prefix delegation. You can uncomment and change these addresses to have control over which address gets, or which prefix address gets assigned to the device. And likewise, similar to the next address setting, there is a next prefix setting that can be used for changing and reassigning the prefix to the device in some tests. So jumping back, here are the basic settings that you use. So disabling prefix delegation, set the enable testvar to no, or set it to yes to enable it. And if prefix delegation is enabled in CDRouter, CDRouter will wait and require that the device request a prefix before continuing on to running tests. So in the start procedure, you'll be able to trace this activity and verify that a prefix was requested and assigned to the device before the initialization is completed. So now I'm going to turn over to the Lands section. This is the section that controls how CDRouter's LAN clients receive their own IPv6 address on the LAN. In the IPv6 add-on section, there is a section for LAN that you can expand. So if we collapse this and scroll back up, and we'll collapse our WAN section. The LAN section falls just below that. And in addition to address settings, there are other sections for assigning, if your device supports DHCP v6 on the LAN and you want to CDRouter's LAN clients to use DHCP v6, you can set your address pool here to match your device. So let me jump over to more specifics. So by default, CDRouter will use auto configuration, and it will just, when it receives a prefix from the device, it will create its own, CDRouter's LAN client will create its own IPv6 address based on that prefix, and an automatically generated an interface identifier. Alternatively, you can have CDRouter use DHCP to obtain an IPv6 address. Your device is going to have a pool of addresses that you'll need to configure on the device itself. You'll need to find out the range of addresses that are available and update your CDRouter config to match that address range using the IPv6 DHCP client start and client end test vars to specify the upper and lower range of that address pool. So that takes care of the how CDRouter's clients, LAN clients, will behave. To determine what prefix is generated on the LAN, we already talked about prefix delegation. So if your device is set up to use DHCP v6 prefix delegation, it will request a prefix on the WAN that it receives from CDRouter's DHCP v6 server on the WAN again. So here we have those settings that we talked about just a minute ago, where we've enabled prefix delegation and we've configured the prefix that CDRouter will send to the device in the IAPD option. By default, CDRouter will send this prefix. CDRouter will send this prefix, and this prefix may be a 64-bit prefix or it may be shorter. Let me jump over here for a second just to clarify that. So I'm going to go back up to the WAN section just to make sure we're all clear here. So in the prefix delegation section, the default prefix length, let me just uncomment these here. So our default prefix length is 48 bits. That means that CDRouter will send an IAPD prefix option with the 3001:DDDD prefix and a prefix length of 48. When the device receives this prefix, it is then going to take that prefix and extract a longer prefix, a 64-bit prefix, to advertise and assign to its LAN interface. And it will advertise this prefix on the LAN for CDRouter's LAN client to receive and use as the prefix for creating its own IP address. So this is controlled and specified using the IPv6 LAN prefix length to reflect that it's going to be a 64-bit prefix. This is pretty universal. Most specifications require a 64-bit prefix on the LAN. If this is different for your setup, you can change it. But basically, we're going to assume that you're using a 64-bit prefix on the LAN. And then there's a subnet ID that your device will automatically assign to the longer prefix. So assuming out of the 64-bit prefix, the first 32 bits of that prefix are 3001:DDDD. The remaining 32 bits can be set with a subnet ID, and you can specify that here. Most devices will assign 0 as the subnet ID or 1. You may be able to specify this manually to some random value. You would need to specify that here so that CDRouter could then determine and calculate the prefix that it expects to see from the device. And so this, if you're using a length of 64 with a subnet ID of 1, this would be the final prefix that the device is going to advertise on the LAN and that CDRouter will use for creating its own IP address. So with this full prefix, CDRouter's LAN client would then use the method that it's configured for to assign an address if it's using auto configuration. If you're not using prefix delegation, then you're going to need to manually configure a prefix on the device. And then that prefix will need to be entered into your CDRouter config file manually to make sure that it matches. Again, we've got the prefix delegation, the enable PD test var set to no. This means that prefix delegation is disabled on CDRouter. And we've set the IPv6 LAN IP test var to match the prefix section will match the prefix that you've set on your device. The lower portion in orange can be omitted here if you're using DHCP 6 for assigning LAN clients addresses. Otherwise, you would want to specify this keyword :EUI64 : What that means is that tells CDRouter that the device under test is going to create its own IPv6 address using a calculated interface identifier, and CDRouter will auto-detect that during the startup phase based on device detection, duplicate address detection. It will determine what IP address the device has assigned for itself. But once you've entered the prefix and the prefix length that you've configured, once you've set a prefix and a prefix length on your device for use on the LAN, you'll need to enter that prefix in the LAN IP section, and you'll have to set the IPv6 LAN prefix length to the same prefix that you're using on the LAN. And in most cases, that should be 64. So here I just talk more detail about the address that the device is going to create for itself. Most devices do create an address for themselves on the LAN, and some tests do rely on this. Not all devices do it, but for those that do it, they can either do it explicitly through manual configuration, or they can create it on the fly, in which case you account for this using that EUI64 token to tell CDRouter to automatically determine what that LAN interface is. So that's the basics of setting up CDRouter on the LAN and the WAN, and configuring address assignment. Here I've got a configuration file that we're using in our lab, and I'm just going to go through and show that by default, when you start a new configuration file, all test vars are commented out, and we'll use anything that's commented out or missing from the config file we'll use a default value. So as you can see here, let me expand this a little bit. Any address, you can select these addresses and see some information over here on the right hand side, and you can see that there's a default value of no inserted here. So if this test var were commented out or missing from the config file, CDRouter would use a value of no here. So by doing that, you can take an initial config file with all test vars commented out and simply leave them as is for the default setup to work, or just change the minimum number of values to have your setup match your device. So in this case, we've left the WAN address assignment to DHCP v6, and we're just using the default addresses. We've enabled prefix delegation, so all we did here was set the DHCP v6 WAN enable PD to yes, and make sure that it's uncommented. And in the LAN section, we've left it autoconf. The LAN mode is autoconf. We left that as a default. And we've just set the LAN subnet ID to FFFF, which is what the device is using when it creates a prefix for the LAN based on the prefix delegation prefix received on the LAN. And then the device's pool of addresses starts at ::2 through 1F. And so we've adjusted this, and that actually is the default, so that doesn't need to be set. But if the pool differed from this range 2 to 1F, we would then have to uncomment these and set them. And that's pretty much it. So a very small number of changes need to be made to set up a test here. So here I have a test log where with these settings, and if you collapse all of the sections, you can kind of see a summary overview. First, CDRouter initializes its services. And it configures IPv6 here. This is just setting up its interface and sending out an advertisement based on the prefix that it's using. It initializes its DHCP server, shows that it's running prefix delegation with this prefix using 3001 DDDD and a 48-bit prefix. Starts DHCP servers, NTP servers, and then it starts the WAN services. Here it waits for, now because it's running in DHCP mode, it waits for the device to request an address. And we can see here we receive a solicit from the device. And CDRouter responds with an advertised message. And then there's a request. And CDRouter assigns an address and a prefix. You can see that we received an IANA option as well as an IAPD option from the device. And then by clicking on the packets here, you can see the contents of the DHCP assignment. So we have an address assignment with an address. And we have by default, there's a lifetime of 300 seconds for the address. And you can see this 3001::2, that corresponds to the address that we assigned up here. It's the IPv6 WAN ISP assign IP address. This preferred lifetime and valid lifetime, those are also in the config file under DHCP server, where you can set the valid lifetime and the preferred lifetime. And you can change those at will. Likewise with prefix delegation, those same lifetimes will be applied to both address assignments and prefix assignments, so you don't have a separate set. But you can see in the results here, the prefix is assigned. We have 3001 DD with 48-bit prefix. And the preferred and valid lifetimes are 300 seconds. So once these assignments are made, then CDRouter then moves on to initialize the rest of the test setup. It waits 30 seconds for the device to receive the prefix, create a new prefix for the LAN, and assign it. So after the 30 seconds elapse, CDRouter creates an IPv6 client on the LAN, and it's using auto configuration, so it sends a neighbor solicitation, a router solicitation, and waits for a router advertisement from the device. And when it receives one, it examines the contents and ensures that the expected prefix is there. So here we say so this one did not contain a prefix option, so we continue to wait. Until we finally receive a router advertisement that does contain a prefix option. And CDRouter logs that. Oops. It says router is advertising its prefix. It's a 64-bit prefix with a subnet of 1 added to it. When we look at the prefix contents, you can see that this address has both the onLink set flag and the autoconfig A flag set. This means that the prefix can be used for auto configuration, auto address assignment. And then CDRouter takes that and creates its own IP address using its own EUI64 interface identifier by adding that to the prefix. So that's the basis of getting your address assignment. Now CDRouter's LAN client has an address. And the rest of the test setup proceeds by performing path MTU to determine the MTU size that CDRouter's LAN clients can use. It sends large packets over the LAN to be forwarded over by the device over to the WAN and waits for ICMPv6 two big messages to be received until it determines the maximum size of the packet that can be sent on the LAN. The results are a little bit confusing just because there's so many DNS requests going on here as well. But we'll scroll down until we receive alright, so I don't have an example of that here. So we use a default MTU size. And then CDRouter verifies that it can forward traffic from LAN to WAN by sending an echo request to a remote destination. So clearly we have a setup that's not fully working for connectivity here. In any case, that's the basics of the address setup. What I want to go over to now was just to cover some of the other modes that CDRouter works in for IPv6 using transition mechanisms where you can have IPv6 hosts on the LAN side of the device and the device operating in either 6-4 or 6RD tunneling mode, where it will take those IPv6 packets, encapsulate them in IPv4 over to a server, a relay server. So 6-4 is a mechanism of encapsulating the IPv6 traffic in IPv4. It uses a number of predefined values for setting the prefix and translating between an IPv4 address and an IPv6 prefix. Basically, when the device receives an IPv4 address, a public IPv4 address from its ISP, it translates that into a hex value to use directly as its IPv6, as part of its IPv6 prefix. So to configure this, you'll need to set the IPv6 WAN mode to 6 to 4. Since we're not using IPv6 directly on the WAN, we're not using DHCP or AutoComp, we're setting it to 6 to 4. In that mode, CDRouter, the device should be using its public IP address. So to get the public IPv4 address, you look at the WAN ISP assign IP address. And here we have that as 202.254.1.2. And then to complete the prefix address, we're going to add a fixed 6 to 4 prefix next to there's a 6 to 4 prefix of 2002. That's a statically assigned, well-known prefix number used for 64. Concatenate that with the IPv4 address, and then after that a subnet ID of a 16-bit subnet ID that can be configured. So the 2002 is also a 16-bit, so together that makes a full 64-bit prefix. 2002 followed by the IPv4 address of the device, followed by a subnet ID. The subnet ID is something that would be configured on the device, and you would need to make sure that it matches the IPv6 Lands subnet ID test var in your config file. There's also an IPv6 relay server. By default, in 6 to 4 mode, this must be 192.88.99.1. This is an Anycast server that would exist in your network in the real world if you were operating in this mode. And that address should remain the same. So in this mode, that would allow, CDRouter will then test the device to ensure that it can properly encapsulate and forward IPv6 traffic from the LAN and forward it over to the relay server. And CDRouter will validate that the source address, or that the address that the device is using, conforms to the 6 to 4 prefix by including the 2002 with the assigned IPv6 as IPv4 address in hex and the configured prefix. Now there's another mode called 6RD, which is a more generalized version of the 6 to 4 mechanism. It uses the same concepts of a prefix value followed by the IPv4 address of the device, followed by a subnet ID, and as well as a relay server. But most of these parameters are a little bit more flexible than the 6 to 4 mechanism allowed. So in this case, we're going to change the IPv6 WAN mode to 6RD. We still have the WAN ISP assign IP, which specifies the IPv4 address of the device. That's going to make up part of the prefix. But in this case, the 6RD prefix is more flexible. It's not just a 16-bit value. It's a floating value, floating length value. So you may assign any prefix and a length along with it. Likewise, there's this IPv6 Rd IPv4 mask length specifies the number of bits from the end of the IPv4 address, basically the most significant number of bits. In this case, it's set to 8, so only the 2 would be assigned. Only the 2 out of this IPv4 address is used in the prefix. And then we have a subnet ID, which is also variable length and can be any value that fits within the length. The length of the subnet ID is dependent on the length of the 6RD prefix length and the number of bits in the mask. So we have an example down here where we have a 20-bit prefix of 2009:F, and those 20 bits, following those 20 bits are 8 bits out of the IPv4 address. Sorry, I've taken that out the other way around. 20 bits, the 8 bits are stripped off, leaving the most significant bits of the IPv4 address. Basically, the host ID of the device is dropped off, and only the first 24 bits. So we have the 202.254.1. Sorry, the 254.1.2 dropped off. And used. So 2009:F concatenated with 254.1.2 in hex, and then following that is the value 10, or the value of 10 in hex, which is A, to create a prefix of 2009:FFE0:1020. That's the RD prefix along with the 24 bits from the IPv4 address, and then followed by the 0A of the subnet ID. This is explained in more detail also on the support site. So if you have any questions about these configuration values, you can go to support.qacafe.com. There you can find our user guide for the IPv6 add-on. The IPv6 CDRouter IPv6 user guide contains a configuration section which explains the different WAN modes that I described here and a number of different example scenarios. It explains each of the test bars and their meanings. There's also a section for these transition mechanisms. And then also in our knowledge base, if you do want to configure something like 6-4, we have a few different articles that help explain this in more detail. So these two articles provide an overview of how to configure 6-4 and 6RD, a more detailed setup with labels to explain which addresses are used and how they're used in the prefix, as well as a sample configuration. There's another article here that explains the technology in a little bit more detail. And then also provides a more simplified example. So I encourage you to consult that as well if you have any questions. Somebody asked about setting up multiple LAN environments. If you have, this is certainly possible. CDRouter by default creates one LAN client on its LAN interface specified. I'll jump back to the presentation here. There we are. So, in your basic CDRouter setup, you have a LAN interface and a WAN interface. This is configured in the IPv4 section. So, by default, for each WAN interface and each LAN interface, there is one IPv4 stack and one IPv6 stack if IPv6 is enabled. You can have multiple LAN interfaces if you have the MultiPort add-on option included in your CDRouter license. In that case, with CDRouter MultiPort, we'll jump to our configuration. So here we have our configuration file, and in the IPv6 add-on section, we've configured our default WAN and LAN interfaces here. And that will be our address assignments. For an additional LAN interface, we will jump down to the MultiPort section, where we have WAN and LAN settings. So under LAN, we could expand that and define one or more additional LAN interfaces. So these are logical LAN interfaces. So if we wanted another IPv6 LAN client on a different interface, we would expand the IPv6 LAN section here. And we could copy any of the IPv6 settings into this section. It's not just limited to these. But essentially, for a secondary LAN client, we would just enable it here. You would have to remove the ignore keyword, and that would define a new testvar group for this LAN interface. Under the IPv4 section, you can specify which interface is used here. This would have to be a different physical interface connected to your device. So CDRouter would only be able to support one LAN client per interface in this manner. So I hope this information has been useful for getting you educated and up to speed on setting up CDRouter for IPv6 testing with your devices. If you do have any questions, certainly please don't hesitate to check out the resources that are available on our website, both the knowledge base and the user guides. They all contain sample configurations and information. And if you have any trouble with your testing, once you've run a test, and if you're having trouble getting through the start procedure and getting your test environment initialized so it can run tests, or if you're having trouble with any of the individual tests that are available, and I'll show you the test modules that are available with IPv6. There's quite a large number of tests for verifying basic connectivity and basic IPv6 headers information. We also have for the different WAN modes for DHCP V6 and auto configuration or 6-4 or 6RD, and then various protocols that run over V6. If you have any trouble running these tests, feel free to contact us at support@qacafe.com. Please send us a copy of your results. You can get a copy by exporting your results by clicking the .zip button here in your results. That will create an archive that you can save and then email to us, and that will give us all of the test logs and capture files to help us analyze what's going on in the test results and provide some suggestions and help for you. So once again, thank you very much for attending, and I hope you have a great day. Take care.